Well, we have another question here, question 9. The question says that given f of x equal to 3x squared. I'm gonna write the question over here. Question 9. What we have is fine. F of x is equal to 3x to the power of 3. Okay. And now question 9.1. The question says that as you can see, 9.1. Solve for solve f of x equal to f prime of x. So f, okay, so we have like, let's say question 9.1 says f of x equal to f prime of x. Now let's first work out f of x is already given, and then we need to calculate f prime of x. But before we do, let's first talk, say how we differentiate the function. Okay, each term of the function given the form ax to the power of n, okay, the derivative will be n times a times x to the n minus 1. Okay, so in this situation, because f of x is just 3x to the power of 3, f prime of x would then be, okay, this is a and then this is n. So following this formula, okay, it's gonna be like 3 times x to the power of 3 minus 1. So this would make f prime of x will be equal to 9x squared. Now we're gonna set the two equal. So the two functions equal, f of x and f prime of x. F of x equal f prime of x will then become like 3x cubed equal to 9x squared. Okay, so I'm going to move the 9x squared over this other side of the equal sign, and then this will become like 3x cubed minus 9x squared equal to 0. Now over here I'm going to take a common factor between the two terms. We can see that 3 is a common factor, so it's going to be like 3x squared for the common factor, and then in the bracket will be like, it's going to be like 3x minus, no, not 3x actually, it's going to be x minus 3, and that's equal to 0. So this is 0 if 3x squared equal to 0 or x minus 3 equal to 0. So over here we can work out x will be equal to 0 or x equal to just 3. So those are the values of x for which the functions and its derivative are equal. Okay, and now the following question is question 9.2. The question says that the graphs f prime and f second are all pass through the point 0, 0. Now 9.2.1 says for which of the graphs will the point 0, 0 be a stationary point. Okay. Okay, let's read it over. The question says solve for 9.2 says that the graph of f prime and f second, which is the second derivative, all passes through the point 0, 0. Now 9.2.1 says for which of the graphs will 0, 0 be a stationary point. All right, I'm gonna move my board over here. Okay, let's just do it over here. Okay, we need to understand what is the stationary point. Okay, stationary point is I'll say the stationary point is also a turning point. It has the same meaning. Okay, so because f is a cubic function actually. Okay, a cubic function. It's not mentioned, but it is a cubic function. Stationary point this will have a stationary point f, okay, because cubic function has stationary point, and then f prime also has a stationary point, which is the turning point, okay, the maximum or the minimum. But f second, this is a straight line. Okay, let me see. This is going to be a cubic function. This one will be cubic function with x cube. This one is going to be with x squared, and this one will have a x only, not exponent, not an exponent. So this will be a straight line. I wanted to say cubic. I just write x cubed to abbreviate. This is cubic. This is quadratic. These two have stationary points, but f second is a straight line. Straight line doesn't have any stationary points or any turning points. So the graphs here are just the graphs for which 0, 0 will be a stationary point is the graph of f and the graph of f prime. Okay, now question 9.2 says that explain the difference, if any, in the stationary points referred to in question 9.2.1. All right. Okay, for f, for instance, the stationary point here is a point of inflection. Okay, for this one, this is the point of f, is a point of inflection. And then for the cubic function here, f is a point of inflection, but for f prime, this will be the turning point, the TP. Okay. So stationary points, I said, are turning points, but they're turning points and also the point of inflection. Okay, and then the next question will be question 9.3. Here the question says that determine the vertical distance between the graphs of f prime and f second at x equal to 1. Okay. Remember that the vertical distance are just the change between the y's, okay, or in other words, the f of x. So I'm gonna do it over here. Let me do it over here. Move my board like this. 9.3. So we're looking for, basically we're looking for f of 1 minus f prime of 1. Okay, so this is what we're looking for. Now, first of all, it is given that f of x was equal to 3x cubed. Okay. Oh no, we're looking for the difference between f prime of 1 and f second of 1. Yes, the f of x was given by 3x to the power 3. So now f prime of x we calculated in the previous question. It's gonna be, it was 9x squared, and then now we're gonna work out f second of x. Okay, this will be the derivative of this following that formula. It's going to be like 2 times 9 times x to the power of 2 minus 1. And this is equal to 18x. Okay, a straight line. 18x is straight line. So straight line they don't have a point of inflection, or don't have a turning point. Now, so we're looking for the difference between the vertical difference between f prime and f second at x is equal to 1. Now, let's see. At x is equal to 1, okay, f prime of 1 will be equal to 9 there, and then here also it's going to be like 18. So I'm going to sub in 1 there and 1 there, and this will be like, okay, 1 here, 1 there also. So this will be like f prime of 1 is this going to be just 9, and then this will be excuse me, it's going to be 18. So the difference here will be the difference will be um, the distance we must be consider the absolute value. It means we don't take the negative sign, okay? So I prefer to take the highest minus the smallest. So in this case, I say f prime of 1 minus f second. Okay, I prefer just to reverse the order. It doesn't change anything. Okay, maybe let's leave it like that. If I do f prime of 1 and f second of 1, this would be like 9 minus 18, and this is going to be negative 9. But the distance, you don't write negative 9, the distance must be positive, okay? So 9 units is the distance. 9 units, the vertical distance. Okay. Now the following question, I guess the last one, yes, it's the last also, is question 9.4. The question here says that for which value or values of x will f of x minus f prime of x be lesser than 0? All right, now I'll move the board this way. Okay, this will be, yeah, I'll move it here like that. So, 9.4. So we're looking for the value of x or values of x for which f of x will minus f prime of x will be lesser than 0. Now let's do that. So we did okay. F of x is given by 3x squared, and then f prime of x is 9x squared, as we did earlier. It's lesser than 0. Now we did work out, so we did set 3 to the power of x. Okay, I meant to the power of 3 there. I did put like x squared as a common factor, and then this will be like x minus 3 lesser than 0. So now this is possible. So now lesser than 0, we can do this by using the number line, for instance, or maybe even before we do the number line, it is important to note that this part here is strictly positive, okay? Because 3 is positive and x squared is also will always be positive, okay? So 3x squared, let me say that 3x squared is always positive. You know, to have like a product lesser than 0, it's either it's when one the sign alternates, one is positive, the other negative, or one is negative, this is positive. Then we can have like a negative. Negative means less than 0. Okay, negative is equivalent to less than 0. Now, in this situation, we already have like 3x squared positive, so x minus 3 has to be lesser than 0. So we're going to set x minus 3 lesser than 0. So this means x must be lesser than 3. So if x is lesser than 3, we have this f of x minus f of x will be will be lesser than 0. There must be a condition, because 3x squared has to be also more than 0. So this was positive already. No, it's okay. So it's gonna be like that. The other thing is the only condition is that x cannot be 0, because if x is 0, you sub 0 there, 0 there, can be 0 must be less. This will be 0 less than 0, which is untrue. So it's going to be x lesser than 3, but x is different than 0. Thank you.